Alrighty, I want to talk about how we draw free body diagrams for objects on an inclined plane. Specifically, I want to understand and explain why we put the angle of the incline in between the force of gravity vector and the y-axis. But before we dive into that, let's just draw a free body diagram for an object on an inclined plane. So here we have our surface that's at an angle, and we have an object just sitting on the inclined plane. I like to start by drawing my x and y axis. Notice our x and y axis have actually been tilted because of the incline of the surface. Now, even though the axes are tilted, the force of gravity still points straight down, and the normal vector is still perpendicular to the surface, so we can draw it along the y-axis just like this. And now this is where we place the angle of the incline, right between the force of gravity vector and the y-axis. And now this angle is very important. It allows us to calculate the x and y components of the force of gravity. And you can use trigonometry to show that the y component of gravity is equal to mg cos theta, and the x component of gravity is equal to mg sine theta. And really, other than friction and some applied forces, this is what a free body diagram for an object on an inclined plane will look like. But now let's get to the important question. How did I know to put the angle there? How did I know that that angle is the same angle as the inclined plane? And that's what one of my students asked me. And honestly, I didn't have a good enough understanding to give them an answer. And so I woke up today knowing I needed to figure out why we put the angle there. And what I figured out is that all I needed to understand this was the Z-theorem. But before we get there, let's start by redrawing our free body diagram. So we have our inclined plane with our angle, we have our object, we have our tilted x and y axes, and then we have the force of gravity vector pointing straight down. And now from our previous free body diagram, we know that that angle right there is equal to the angle of the inclined plane. But I want to show you how we know this. In order to do this, we will need to understand the Z-theorem. The Z-theorem states that if two lines are parallel, then their alternate interior angles are equal. So what does this look like? Well, if I draw two parallel lines like this, and I have another line cutting through them like this, notice that the lines in green form a Z, and the Z-theorem states that these interior alternate angles are equal. Now let's look back at our free body diagram. I can draw a line like this, and then I can draw a parallel line just like this. And now let's form our Z shape. And we can say, according to the Z-theorem, that these two angles, which I've labeled theta star, are equal. Still looking at our free body diagram, I want you to notice the 90-degree angles that we formed here and here. And so now we've got all this information, but how can it help us solve for this angle? Well, we know that all of the angles in a triangle have to add up to 180 degrees. So that means that this angle must be equal to 180 degrees minus 90 degrees, that's from this angle here, minus theta star, our angle that we found here. Now let's take a look at this triangle. This angle must be equal to 180 degrees minus 90 degrees, which comes from here, minus theta star, which comes from here. And now what I hope you can see is that both angles are equal to the exact same thing. And that's because they're the same angle. And so using the Z-theorem, I just showed why the angle of the inclined plane is equal to the angle between the force of gravity vector and the y-axis. And so that is where my explanation ends, because honestly, that's where my understanding ends. I wish I could tell you that I understood it on a deeper level, but truly, the Z theorem is the only way that I've been able to conceptualize and visualize how those angles are the same. If you've got a better way of understanding this or a better way of describing it, please let me know in the comments because this was a real challenge for me. And I'm really excited to learn how to explain this and how to understand this differently. Anyways, thanks for listening, and I'll see you soon.